Hello, welcome. This is a video on series, and let's jump right into this. This emerging question asks us to write out the terms in the series below. Notice that n equals 3 is the lower limit, and so we would put 3 in for n squared. Now 3 squared is 9. Remember, this is a series, not a sequence, so we're going to put plus signs, not commas. So then 4 squared would be 16. 5 squared, 25. 6 squared, 36. And 7 squared, 49. All right, and this next one, it says write the following series using sigma notation. And so I'm looking like how would you get from 2 to 1? You could subtract 1, but if you subtract 1 again from 1, it should be 0, and it's 1/2. So it seems to be a geometric series. If I take 2 and divide by 2, they give me 1. And if I take 1 and divide by 2, I get 1/2. And I divide by 2, I get 1/4. And so it would appear that the common ratio is 1/2. And so if we're going to write this using sigma notation, our initial value, we're going to say k equals 1. And there are 1, 2, 3, 4, 5, 6 numbers. So we would put 6 in here. And then the equation that we would put in here is the first term, 2, times the common ratio, which is 1/2, raised to the power k minus 1. And that's how we do this. All right, in this next one, it says to find the sum of the following series. And with 1 being the lower limit, 5 being the upper limit, one way to do this would just be to list them. So I could say I've got 1 times 3 would be 3 plus 2, 5, plus 2 times 3 is 6, plus 2 would be 8. And then notice that each time it's going up by 3. And so the next one would be 11, and then 14. And then finally when n is 5, that's 5 times 3, which is 15, times 2 would be 17. And then you can just add those and put those in your calculator, and that would give you the sum. Another way to do it is to use the formula. There's a formula for arithmetic sequences for this, a formula for arithmetic series, excuse me. So S sub n is equal to n over 2 times a sub 1 plus a sub n. And n, in this case, because there are 5 terms, n is 5. And a sub 1 is the first term, which is also 5. And a sub n is the last term, and that's 17. And so now that we have this, the last term, we could calculate it this way. So a 5/2 times a sub 1 is 5 plus 17. And this we could put in the calculator, and it would give us 5/2. Let's do this. 5/2. And we're going to multiply that by 5 plus 17. And that would give us 55. But just to kind of show that that works, we can also just plug that in. 5 plus 8 plus 11 plus 14 plus 17. And yes, that's 55. All right, and then finally, on this problem, we're asked to find the sum of the following series. But in this case, it looks like it's arithmetic. If I add 3 to 4, I get 7. If I add 3 to 7, I get 10. If I add 3 to 10, I get 13, and so on. And so the common difference is 3. And so I can use the generalized formula a sub n for an arithmetic sequence is a sub 1 plus n minus 1 times the common difference. And then we can plug this in. Now we know that the last number is 31. What we don't know is how many numbers there are because of this ... There could be a lot of different numbers in there. So we have to figure out how many there are. 31 is equal to a sub 1, which is 4, plus n minus 1 times the common difference, which is 3. And so if I distribute that, I get 31 is equal to 4 plus 3n minus 3. These two combined would give us 1 plus 3n. If I subtract both 1 from both sides, I'd get 30 is equal to 3n. Then dividing both sides by 3, n equals 10. And now I know what n is. I can go back and use this formula that we just talked about in this prior problem. S sub n is equal to n over 2 times a sub 1 plus a sub n. Now that we know that n is 10, we can say this is equal to 10 divided by 2 times the quantity 4 plus 31. And I can plug that in. I'm going to just go ahead and simplify. This is 5. 4 plus 31 would be 35. And so really all you need to do is multiply it. 5 times 35. And that would give me 175. And that's how we do it.